So let's look at an example using tangent, because as I said in our first lecture on solving equations, we treat tangent a little bit differently. And notice again, we have the same equation, but I'm asking you to answer it in 3 different ways. What I've noticed when I've checked exam answers is that people don't pay attention to what's being asked for. If I ask for question 1, they give me the general formula. If I ask for question 2, they give me only the interval 0 to 2 pi radians. You need to read carefully and answer what is being asked for. That's why we're using the same equation over and over again, so you can see that there are different ways to answer the question. However, in order to answer question 2, we need to answer question 1 first. I need the answers from 0 to 2 pi radians. In order to answer question 3, I need the formula from question 2, which means I also need question 1. That's what makes question 3 such a good exam question. It gives me an answer for the question 1 on an interval. It gives me the general formula and asks you to use the formula. But be careful, read carefully. So let's go back and why don't you go ahead and solve this equation on the interval 0 to 2 pi radians. You isolated tan theta, and using the cast rule, you found that tangent is negative in quadrant 2 and in quadrant 4. After drawing your triangle in each quadrant, although you may just be using points on the unit circle, you needed to find the reference angle, and then you were able to find theta. So your answer in quadrant 2 was 150 degrees or 5 pi by 6 radians, and in quadrant 4, 30 degrees less than 360, 330 degrees or 11 pi by 6 radians. Now, in question 2, we're asked to find the general formula for all possible solutions. And I want you to remember from the first lesson this week that we said for tangent, we're applying the formula only to quadrant 1 or quadrant 2. We don't have a quadrant 1 answer here. We only have a quadrant 2 answer. So in quadrant 2, where theta is equal to 150 degrees, we can apply the general formula. Tangent repeats every 180 degrees K. Or if we're talking about radians, plus pi K, where K is any integer. Now you're wondering, why do we only require one formula? Well, let's look at this. If we have the tangent of 150 degrees, and we'll talk about 150 degrees just because it's a little bit easier to think about. If I add the 180, (150 plus 180) is equal to 330 degrees. And if I add another 180 degrees, it takes me right back to the exact same spot. Every 180 degrees, I end up in the opposite quadrant. That would be true if I started in quadrant 1 and added 180 degrees. 180 degrees would take me to quadrant 3. Tangent is positive in quadrant 1 and 3. So I don't need 2 formula. And in fact, you would be marked wrong if you give 2 of them. So be careful when you're solving with tangent and cotangent. Only 1 formula is needed using either quadrant 1 or quadrant 2, not both. All right, why don't you find 4 possible solutions given our general formula? By substituting in these values of K, we found these answers for theta. Make sure you write them in radians as well. So let's solve one more problem in this lecture. So you can see it's a little bit different. We have 4 times cosine squared theta equals 1, and we're solving this only on the interval 0 to 2 pi radians. Let's do it together. We're going to isolate cosine squared theta first of all. And then, of course, we're going to take the square root of both sides so that we don't have cosine squared. Did you remember the plus or minus? If you didn't, you need to get out your red pen and put a big reminder here. Every time you apply a square root sign in an equation, you need to look at both the positive and the negative answers. If we're solving on the interval 0 to 2 pi radians, and cosine is both positive and negative a half, that means we have an answer in every quadrant. Now, it's not necessary to draw the triangle in every quadrant. Let's just draw it in quadrant 1 and see what we can do from there. Or maybe you've got that point on the unit circle from quadrant 1 memorized. Cosine is x over r. We need to find our reference angle, which is, of course, from the positive x-axis to the hypotenuse. I hope you know that it's 60 degrees. If you've memorized that point on the unit circle, you should have had that as well. So we know that we have a quadrant 1 answer. In quadrant 1, theta is going to equal 60 degrees. What happens in quadrant 2? Well, you should know we're going to have the same triangle with the same reference angle. Theta will be 60 degrees less than 180. What about in quadrant 3? Same triangle, 60 degrees more. Quadrant 4, same triangle. Find all of the solutions for theta in each quadrant. And of course, we were given an interval in radians, so your answer needs to be in radians here. As always, I would suggest you take some time now to practice either from your e-text or in Pearson MyLab homework so that you're comfortable with these equations before we move on to solving other types of trig equations.